Okay, so hello aspirants. I hope all of you are doing perfectly well. And right now, our question is in front of you all. जल्दी से आप लोग ज्वाइन कर जाओ और ज्वाइन करने के बाद मुझे एक बार बता दो कि if you all can see the screen properly or not, and if you all can hear my voice properly or not. If everything is fine, then we can initiate. सबसे पहले देखो क्वेश्चन में क्या लिखा गया है, उसके बाद इसे सॉल्व करना। क्वेश्चन में पहले कहा गया है कि फिगर शोज अ स्मूथ ट्रैक, a part of which is a circle of radius r. A block of mass m is pushed against a spring of spring constant k fixed at the left end and is then released. Find the initial compression of the spring so that the block presses the track with a force mg when it reaches the point P. Good, where the radius of the track is horizontal. Where the radius of the track is horizontal, there the ball is actually there, the block is pushes the track with some force P. Okay, that means the normal reaction is P actually. That's all I can say. So we know one thing in mostly in this case of questions, these types of questions, that there is a relation actually. You can just use that thing anywhere. So at any point of time during the motion in a vertical circle, we know that suppose if this is your circle, vertical circle, the particle is here. So this is mg. So mg can be resolved into two components. So this angle can be taken as, just hang on for a moment. If this is a vertical circle, your particle is here. So it has two forces, mg. You can resolve mg into components. Mg, this angle is theta. So mg cos theta. This is your mg sin theta. And of course, the normal reaction should be in the upward direction. This direction you will get an m. So we know that n minus mg cos theta should be equals to mv square by r. Or if this is the tension in the string, so tension would also act in the above. So T minus mg cos theta should be equals to mv square by r. Then from there you can just find out the normal reaction. N is equals to mv square by r plus mg cos theta. So that is very important. So we can just write it down. We know that normal reaction minus mg cos theta, mg cos theta should be equals to mv square by r. That should actually directed inside. And therefore from here I can tell you that normal reaction is equals to mv square by r plus mg cos theta. Now this is the vertical circle. When it is horizontal, so this angle is making theta is 90 degree. At point P, theta is 90. So cos 90 is 0. Now at point P, find the initial compression of the spring. Okay. So that the block presses the track with a force mg when it reaches the point P. Okay, fine. At point P, n has been mentioned to be equals to mg in the question, and theta we know is 90 degree, and therefore we can again write cos 90 is 0, n is your mg, so mg is actually equals to mv square, vp square by r. So AMM get cancels out, and from here I can get the value of VP. That is the velocity at the point P is actually root over of, what is it? GR. If this is root over of GR, what is the velocity at the bottommost point? What is the velocity over here? If this is the velocity at this point P, so what is the velocity at the bottommost point? See, at the bottommost point, it must have some kinetic energy, half m v square, but no potential energy. At the point P, it has a potential energy plus the kinetic energy. Now let's apply mechanical energy conservation. Conservation of mechanical energy. Mechanical energy between P and O. Say this point is O, I guess. So I can just write it down as, at the point O, half mVo square plus potential energy is 0 there, which should be actually equals to, at the point P, it is half mVp square. The kinetic energy plus the potential energy will be this height. At the point P, this height is actually equals to R, so mgr. And from here, you can tell me, you know that Vp is equals to root over of gr, right? So Vp square is gr simply. Mm can be cancelled out, half of can be cancelled out, so V naught square is basically equals to gr plus 2mgr, and therefore not m, just only 2gr, that is 3gr, which says, so V naught square is 3gr. Now initially the spring was compressed. When the spring was compressed, say by a distance x, so half kx square, that entire energy will be converted to the mechanical energy or the kinetic energy. So that thing is actually is equals to half kx square. Again, if initially the compression in the spring is equal to x, then half kx square should be equals to half m v naught square. From there I can get x square is equal to, see, half of cancels out, m by k v naught square. M by k v naught square, we know that v naught square is 3gr, so 3gr, 3mgr by k is basically your x square, and therefore x is root over of 3mgr divided by k. X is your root over of 3mgr divided by k. That is the answer. 3mgr divided by k. बताओ ये समझ में आया कि नहीं? This is a very important point. X is equals to root over of 3mgr divided by k. R is the radius, जिसे हमें actually g smaller लिखना चाहिए था हर जगह. g smaller, 3g smaller, तो यहाँ पे भी स्मॉलर आएगा, यहाँ पे भी स्मॉलर आएगा, स्मॉलर इस ट्रैक का रेडियस है, यहाँ पे भी स्मॉलर होगा, स्मॉलर इस ट्रैक का रेडियस है। सो वेलोसिटी एट द पॉइंट P मिल गया, उसके साथ वेलोसिटी एट द पॉइंट 2 को रिलेट कर दिया, यहाँ पे हाफ एम वी नॉट स्क्वायर प्लस 0 इज इक्वल्स टू हाफ एम वी पी स्क्वायर प्लस एम जी आर। तो वहां से मेरा वी नॉट निकल गया, वी नॉट निकला तो हाफ एक्स स्क्वायर इज इक्वल्स टू हाफ एम वी नॉट स्क्वायर, तो यहाँ से एक्स डन। तो आई थिंक दिस क्वेश्चन वाज इजी एंड पीपल हैव गॉट द आंसर ऑफ दिस क्वेश्चन। अब ये वाला हो गया तो हम लोग कोई दूसरा क्वेश्चन ट्राई कर सकते हैं। तब तक बच्चे लोग जरा इस पेपर को देखो एंड आई एम जस्ट टेकिंग अनदर क्वेश्चन। Okay, everyone, please pay attention to this question. क्या बोला गया सवाल में? A particle of mass m is kept on a fixed smooth sphere of radius r at a position where the radius through the particle makes an angle 30 degree with the vertical. Where the radius, okay, on a fixed smooth sphere of radius r at a position where the radius through the particle makes an angle 30 degree with the vertical. The particle is released from this position. What is the force exerted by the sphere on the particle just after the release? Find the distance traveled by the particle before it leaves the contact with the sphere. So this is an easy question actually. You're keeping the particle above the sphere, right? That's a good thing. You're keeping the particle above the sphere. So let's just check what to do. So at what point it will leave the contact? That's what I'm asking. So what is the force exerted by the sphere on the particle just after the release? What is the force exerted by the sphere on the particle just after the release? So you have a sphere here, okay? You have a kind of sphere here, and at an angle of 30 degree from the vertical you have placed that particle. So suppose this is your vertical, at an angle 30 degree, this is 90, 45, 30 should be here. From the vertical you have just placed that particle. Suppose here the particle is, say at an angle of 30 degree you have placed it. This is 30. So when you have placed it over here, what are the equations which you can see? I can see there is a normal reaction. I can see there is an mg which can be resolved into two components. One is mg cos, mg sin. Good. So I can see that mg is acting along this direction. Normal reaction should act along this direction. And I'm very much sure about something. Should act actually on the same line, along the same line. Along the same line. So you see, just because it's rotating in a circle, so you should get mv square by r always equal to if this angle is theta, so this angle is theta, so mg cos theta n, so mg cos theta minus n should be equal to mv square by r in this case, because the particle is outside of the sphere. Mg cos theta minus n should be equal to mv square by r. But at the time of release, the velocity of the particle was 0. Always. Now at time of release, velocity of the particle was 0, and therefore mg 0 equal to mg cos 30 degree minus n, जहां से तुमको मिल जाएगा n is actually equal to cos 30 is sin c root 3 by 2, mg root 3 by 2 or root 3 by 2 mg. Root 3 by 2 mg. Done. So part A has been solved. Part A has been solved. Let's talk about part B. Part A has been solved. Let's talk about part B. Find the distance traveled by the particle before it leaves the contact with the sphere. So you have released that particle, right? So when you have released that particle, the particle is actually traveling. The particle is traveling, and at some point of time, it will leave the contact with the sphere. But let me tell you one thing very, very seriously, कि sphere के साथ जब उसका contact टूट जाएगा, जब पार्टिकल का स्फीयर के साथ कांटेक्ट, तब उसका नॉर्मल रिएक्शन 0 हो जाएगा. ठीक है, तब अगर नॉर्मल रिएक्शन 0 हो गया तो उसका mg cos थीटा शुड बी mv स्क्वायर बाय r, उस पॉइंट पे वेलोसिटी. गुड. तो मैं यहां पे बताऊं, when the particle will lose contact with the sphere, when the particle will lose contact with the sphere, when the particle will lose contact with the sphere, then normal reaction is equal to 0. Let theta is equals to alpha. Then at that point, let theta is equals to alpha at that. So what can I say? mv square by r is equals to mg cos alpha minus 0. mv square by r should be equal to mg cos alpha minus 0, and from there you can get the value of v. So mm cancel out gr cos alpha. V square is gr cos alpha. That implies v square is equal to gr cos alpha. That is velocity square at that point. Now let me tell you. Now let's apply conservation of mechanical energy. Conservation of mechanical energy at the initial and final position. And final position. Final position means theta equals to alpha. At the initial and final position. तो यूज करो इनिशियल पोजीशन पे, तो काइनेटिक एनर्जी इनिशियल प्लस पोटेंशियल एनर्जी इनिशियल, काइनेटिक एनर्जी इनिशियल प्लस पोटेंशियल एनर्जी इनिशियल प्लस काइनेटिक एनर्जी फाइनल इक्वल टू काइनेटिक एनर्जी फाइनल प्लस पोटेंशियल एनर्जी फाइनल. इजी है. इनिशियल काइनेटिक एनर्जी जीरो क्योंकि एट द टाइम ऑफ रिलीज वेलोसिटी जीरो था. पोटेंशियल एनर्जी क्या होगा जरा देखने दो. जिस हाइट पे था अगर मैं मान लूं पोटेंशियल एनर्जी जीरो एट द ग्राउंड, तो ये कितना हाइट ऊंचाई पे था? Okay, this distance, this is your r, right? This is r, so this is r cos theta. This height is r cos theta, this height is r sin theta. This is r, right? So this is r cos theta, r cos 30, sin 30. Okay, r cos 30 plus r. M G r plus r cos 30 should be equals to kinetic energy final is equals to half mv square plus जिस पॉइंट पे लूज कर रहे हैं सपोज दिस इज अल्फा, तो एम जी आर प्लस suppose I don't know, like suppose if the angle is so over here, okay, the particle can lose the contact anywhere, right? So you just have to write down, I don't know if the particle loses the contact over here. Okay, fine. R plus R cos alpha. If alpha is greater than 90 degree, automatically this will become negative. Don't worry. Alpha के ऊपर डिपेंड करता है क्या करूँगा. R plus R cos alpha. That's what I can write. Now you see, m cancel हो जाएगा from all the places. You see v square is gr cos alpha. तो gr cos alpha. तो gr plus gr cos 30, gr cos 30 means root 3 by 2. m cancel. V square by 2 means what? gr by 2 cos alpha. यहाँ पे आ रहा है gr plus gr cos alpha. From here I can say gr cancels out. Okay, take gr cos alpha common from this two part, or maybe you can just cancel gr from all the sides. So it will become equals to gr cancel out, बाकी यहाँ से gr cancel out, तो root 3 by 2, तो cos alpha by 2, यहाँ से gr कैंसिल करोगे तो सिंपली cos alpha. अच्छा एक सेकेंड, gr cos alpha, तो ये 3 by 2 cos alpha, 3 by 2 gr cos alpha आ रहा है, इसके साथ इसको ऐड कर दूंगा तो क्या है, gr cos alpha कॉमन 1 plus is 3 by 2. 3 by 2 cos alpha, हाँ this thing. Okay, good. तो 2 cancel out. Two cancel out. 3 से सिवर, तो cos alpha is 1 by root 3. तो cos alpha I'm getting 1 by root 3, and therefore alpha is equals to cos inverse of 1 by root 3. Cos inverse of 1 by root 3 पे वो स्फीयर से लिखा जाएगा. So what is the angular displacement that it has traveled? फाइंड द डिस्टेंस ट्रेवल बाय द पार्टिकल बिफोर इट लीव्स द कांटेक्ट विद द सरफेस। तो ठीक है, पहले 30 डिग्री में था, अभी अल्फा एंगल पे लीव कर रहा है, देयरफॉर एंगुलर डिस्प्लेसमेंट अल्फा माइनस 30, थर्टी डिग्री का मतलब है पाई बाई 6 रेडियन, अल्फा माइनस 30 एंड लीनियर डिस्प्लेसमेंट होगा फिर तुम्हारा आर इंटू अल्फा माइनस पाई बाई 6, जहां पे अल्फा इज कॉस इनवर्स ऑफ 1/√3, तो आर इंटू कॉस इनवर्स ऑफ 1/√3 minus pi by 6. Cos inverse of 1/√3 minus pi by 6 into r. That's all. This is the problem. Solved. If you have any doubts, you can definitely ask me. Otherwise, we will continue on the next. भाई थीटा कैलकुलेट नहीं कर रहे हैं, जरा देख अल्फा कैलकुलेट करेंगे ना। ये बॉल इस पॉइंट से गिरते गिरते कहां पे आके छोड़ देगा स्फेयर को, तो जरा सोच एमवी पहले तो ये तो हमेशा अप्लाई होगा ना, एमवी स्क्वायर बाय जस्ट बिकॉज़ सर्कुलर पाथ में मूव कर रहा है तो सेंट्रीपिटल फोर्स होना चाहिए जो इनसाइड काम करेगा। यहाँ पे सेंट्रीपिटल फोर्स को छोड़ के कौन से फोर्सेस है, नॉर्मल रिएक्शन है और एमजी है। एमजी का दो कंपोनेंट कर ले, एक तो इधर होगा एमजी साइन थीटा, एक इस तरफ होगा एमजी कॉस थीटा। तो एमजी कॉस थीटा बड़ा होना चाहिए नॉर्मल रिएक्शन से, वरना अंदर की तरफ नेट फोर्स नहीं आएगा। तो mg cos थीटा माइनस n शुड बी और mv स्क्वायर बाय r। अब इनिशियल पोजीशन पे तेरा पार्टिकल का वेलोसिटी 0 था, पार्टिकल रेस्ट से गिरना शुरू किया है, तो v0 पुट कर दो, तो इनिशियल पोजीशन पे नॉर्मल रिएक्शन क्या आएगा, mg cos 30 दैट इज √3/2 mg हो गया। अब मान ले गिरते 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 एट एन एंगल अल्फा पार्टिकल स्फीयर को लिफ्ट कर जा रहा है, मतलब स्फीयर को छोड़ दे रहा है, तो उस पॉइंट पे जगह जहां पे स्फीयर को छोड़ेगा वहां पे उसका नॉर्मल रिएक्शन 0। तो सेम इक्वेशन में फिर से पुट कर mv स्क्वायर बाय r प्लस mg cos अल्फा, मान ले अल्फा एंगल पे वो स्फीयर को छोड़ रहा है, तो वर्टिकल से अल्फा एंगल पे छोड़ रहा है, तो mg cos अल्फा माइनस n इक्वल टू 0 पुट कर दिया, तो यहां से v स्क्वायर क्या आया gr cos अल्फा। अब मैं अगर दोनों जगह पे मैकेनिकल एनर्जी का कंजर्वेशन लगा रहा हूं, तो काइनेटिक एनर्जी इनिशियल प्लस पोटेंशियल एनर्जी इनिशियल इक्वल्स टू काइनेटिक एनर्जी फाइनल प्लस पोटेंशियल एनर्जी फाइनल। तो इनिशियल पॉइंट पे काइनेटिक एनर्जी क्या है, यहां पे काइनेटिक एनर्जी 0 क्योंकि वेलोसिटी 0, पोटेंशियल एनर्जी क्या है r प्लस ये है r cos 30, ये हाइट होगा r cos 30 प्लस ये r, तो r प्लस r cos 30 mgh। फाइनल पॉइंट पे काइनेटिक एनर्जी है हाफ एम वी स्क्वायर, जिस पॉइंट पे स्फीयर को छोड़ देगा वहां पे उसका वेलोसिटी v है, v स्क्वायर हमने निकाल रखा है gr cos अल्फा, तो इट विल बी हाफ एम वी स्क्वायर प्लस उस पॉइंट पे इसका पोटेंशियल क्या होगा mg r प्लस r cos अल्फा। अब यहाँ पे देखो इसको सिंपलीफाई करो, सिंपलीफाई करके अल्फा इक्वल्स टू cos इनवर्स ऑफ 1/√3 आ रहा है। तो एंगुलर डिस्प्लेसमेंट क्या होगा, यहाँ पे इनिशियली था इस पॉइंट पे आके स्फीयर को छोड़ जा रहा है, तो ये एंगल अल्फा है, ये एंगल 30 डिग्री है, तो ये एंगल कितना हुआ, कितना एंगुलर डिस्प्लेसमेंट हुआ अल्फा माइनस 30, अल्फा माइनस 30 मतलब अल्फा माइनस पाई बाई 6, अल्फा माइनस पाई बाई 6 अगर तुम्हारा एंगुलर डिस्प्लेसमेंट है तो लीनियर डिस्प्लेसमेंट कितना होगा r इनटू थीटा, r इनटू अल्फा माइनस पाई बाई 6, दैट्स ऑल। दैट वी कैन डू। इसके बाद हम लोग इस क्वेश्चन को देख सकते हैं। बोला गया पार्टिकल इज सस्पेंडेड फ्रॉम अ फिक्स्ड पॉइंट बाय अ स्ट्रिंग ऑफ लेंथ 5 मीटर। Good. It is projected from the equilibrium position with such a velocity that the string slacks after the particle has reached a height of 8 meter above the lowest point. Find the velocity of the particle just before the string slacks. Find also at what height the particle can raise farther. ठीक है, जस्ट जहां पे स्ट्रिंग स्लैक कर जाएगा वहां पे टेंशन 0। हाँ, सो हमें हमेशा पता है कि अगर ये तुम्हारा वर्टिकल सर्कल है जहां पे पार्टिकल तुम्हारा रोटेट कर रहा है, उस वर्टिकल सर्कल में हमेशा एक चीज ध्यान रखना है भाई, कि किसी भी एक पॉइंट पे अगर तुम्हारा, ये इसका सेंटर है, किसी भी एक पॉइंट पे अगर तुम्हारा पार्टिकल है, सेंटर से यहाँ पे मेरा पार्टिकल है, तो किसी भी एक पॉइंट पे तुम्हारा क्या क्या फोर्सेस काम कर रहे हैं ये ध्यान में होना चाहिए। एक तो टेंशन काम कर रहा है इस तरफ, एक एम जी काम कर रहा है इस तरफ। तो इस तरफ अगर एम जी है तो मुझे पता है कि मैं इसको ले रहा हूँ वर्टिकल। अगर ये मेरा वर्टिकल है तो वर्टिकल से थीटा एंगल में है ये, थीटा। इधर ये है मेरा टेंशन टी। तो ये एंगल अगर थीटा है तो यहां से आई कैन मेक टू एंगल्स, दिस एंड दिस। तो ये होगा एम जी, ये थीटा है तो ये थीटा होगा एम जी कॉस थीटा, ये होगा एम जी साइन थीटा। अब ध्यान रहे बेटा कि एक एम जी साइन थीटा है, एक एम जी कॉस थीटा है। ठीक है, नाउ यू टेल मी। तो डेफिनेटली सर्कुलर पाथ में मूव कर रहा है तो डेफिनेटली हमारा टेंशन जो होगा ज्यादा होना चाहिए एम जी कॉस थीटा से, जो हमारा नेट सेंट्रिपेटल फोर्स देगा। तो एम वी स्क्वायर बाई आर, एम वी स्क्वायर बाई आर जो इनसाइड पॉइंट पे होगा शुड ऑलवेज बी ग्रेटर, I mean, AB square should be inside, so T minus mg cos theta. Good. Now, when the string slacks, tension is zero. When the string slacks, slackens, tension equal to zero. If tension is zero, तो at that point velocity क्या होगा? mv square by r, or say the string slackens at point P. Say the string slackens at point P. At point P. So there tension T will be equal to 0, and I can very well write down then m vp square, velocity at that point, by r should be equal to 0 minus mg cos theta. After the particle has reached a height 8 meter above the lowest point. Okay, good. So I know that from here mm cancels out, vp square is then, what can I say? Yeah, the string will slack, this has to be positive, so vp square should be negative of gr cos theta. That means theta has to be greater than 90. Otherwise, this wouldn't be positive. Vp square has to be positive, so this has to be greater than 90. Now tell me, how can you write in the value of theta? At what angle it will slack? Theta must be greater than 90. So after that, the string will slack. Now tell me, what can you say from this equation? So they say from the ground at a height of 8 meter, the string slacks. At a height of 8 meter, the string slacks. So I know for sure that R plus, so this is the thing, at this point the string slacks. So this is your R, this is your R cos theta, this is R. So R cos theta plus R should be your 8 meter. R plus R cos theta is your 8 meter. It has been mentioned, and I know r equals to 5. So I know r equals, just take r common. So 1 plus cos theta is 8 by 5. R equals to 5. I know. 1 plus cos theta 8 by 5. So theta is cos inverse of 8 by 5 minus 1. That is 3 by 5. So cos inverse of 3 by 5 or cos theta equals to 3 by 5. That I know. The angle at which it will lose contact. Cos theta is your 3 by 5. Cos theta is your 3 by 5. That I know for sure. Now tell me what they have asked. Find the velocity of the particle just before the string slacks. Okay, so Vp square is equals to minus gr cos theta. Okay, hang on, just wait for a moment. I have r, if I take common, so 1 will come on this side, right? Yeah. R plus r cos theta is basically you're saying has to be equals to 8 because 8 meter from the ground. Have I done anything wrong? So tension is T. T minus mg cos theta should be equals to mv square by r. But I know that at the point of slacking, T will be 0. So mv square by r should be equals to minus mg cos theta. Minus s, so theta should be greater than that, right? Yeah. Now, okay, I think somewhere I have done the mistake. That is, okay. At this point, the party string slacks over here. So this is the angle which I'm measuring as theta, right? So what is this length? How will you determine? If this is theta, this is 90 minus theta. This angle is theta, so this angle will be what? 180 minus theta. So this is r cos 180 minus theta plus r. So it should be r cos 180 or pi minus theta should be equals to 8. Now I think it's fine. Because if this angle is theta, so this is 180 minus theta. Good. Now the thing will be fine, yes. So cos pi minus theta is minus. So 1 minus cos theta is this. So cos theta, if I just bring it on this side, so 1 minus 8 by 5 is basically minus 3 by 5. Cos theta is a minus 3 by 5. Because the string slackens. Because if this is your sphere and the string slackens here, so the length will be so this angle is your theta, and I want to know the height. I want to know these values. This is r, this is your pi minus theta, so this is r. यहाँ से यहाँ तक r. So this is your pi minus theta. Pi minus theta. So r cos pi minus theta plus r should be your 8. Good. We know that r equals to 5. And from there percentage is equals to minus 3/5. यहाँ पे अगर लिख दो minus 3/5 तो gr 3/5. Vp square is 3/5 gr. Now r equals to 5, so cancel out 3g means 30. So it becomes equal to 3g. So Vp is 3 into 9.8, whatever I'm getting, root over of that answer. That is 5.42. Vp is 5.42. That implies Vp is your 5.42 meter per second. Then what they have asked? They said find also the height, at what height the particle can raise farther. Okay, so after that things are much easier. So whatever be the velocity here, it will now go with that velocity in the parabolic path. And the maximum height reached. So till it will just reach the height till its entire velocity becomes 0. So at what they have said, to what height the particle can raise farther. Okay, so suppose farther the particle raises a height h, then mgh should be equals to half mvp square plus whatever be the energy at this point, potential energy at this point. H farther, the particle farther so farther the raise of height will be given by this raises a height h. A height h. So mj should be half mvp square. Then tell me, half mvp square means, you see cancel out. So gh is equal to vp square by 2. That means vp square is 3g. So gh should be 3g by 2. Gg cancel out, h should be 1.5 meter. That will be answer. Or actually it has a velocity, it has a velocity along the vertical direction as this. It has a velocity along this direction, right? I just need to find out what angle the velocity is actually making. Okay, hang on. If my particle is over here, so Vp is actually along this direction, you see. Vp is actually along tangential direction. This is my Vp. Can you tell what is the vertical component of Vp? Okay, so I'm trying to find out, this is the velocity, I want to find out this vertical component. I know that this point is making an angle 90 degree with the, this is 90 with the radius. This angle I know theta. Good. So you see, well, this is theta, they say this will also be equal to theta. Because if I just carry out this line, it should be this. This is 90 degree, right? This is 90 degree. This is theta. So this is pi minus theta. If this is theta, this is pi minus theta. This is 90. So this has to be equal to something. What is it? Pi minus 90 plus pi minus theta minus 90 theta minus 90. So this angle is theta minus 90. And if this and this, so this angle should be equal to this. Okay, good. If this is theta minus 90, so this has to be also equal to theta minus 90. So this is velocity, it has a vertical component of v cos theta minus 90. It has a vertical component of v cos theta minus 90. Good, good. I think we have got it. It has a vertical component of v cos theta minus 90. Let's do it. यहाँ पे ये जो वेलोसिटी है वर्टिकल के साथ थीटा माइनस 90 एंगल कर रहा है, तो m vp cos थीटा माइनस 90 का होल स्क्वायर, जहां से तुम्हारा आंसर आएगा आप तुम सॉल्व कर सकते हो. सी cos थीटा माइनस 90 cos 90 माइनस थीटा द सेम थिंग, सो दिस इज sin थीटा. तो vp स्क्वायर sin स्क्वायर थीटा, ये हो जाएगा तुम्हारा vp स्क्वायर sin स्क्वायर थीटा. हो गया. अच्छा, vp स्क्वायर मतलब क्या है? vp स्क्वायर मतलब बेसिकली 3g, g कैंसिल, तो h इज इक्वल टू 3/2 sin स्क्वायर थीटा. So the cos theta is this 1 minus cos square theta is sin square theta, तो 9/25, तो ये तुम्हारा 16/25 आ जाएगा. थ्री बाई टू इंटू 16/25 डन. 2 से सो काटो 8, 24/25. Zero 0.96. meter. Actually, with the vertical, let's make an angle theta minus 90. With the vertical, it's making an angle of theta minus 90. This angle is theta minus 90. This angle, I can tell. ठीक है, इसको अगर इधर करोगे तो ये यहाँ पे जाके कट करेगा, तो ये अगर पाई माइनस थीटा है, ये 90 है, तो वो थीटा माइनस 90 होगा, तो वो एंगल और ये एंगल सेम होगा, ये थीटा माइनस 90 होगा. चलो, थैंक यू वेरी मच. मैं क्लास को यहाँ पे खत्म कर रहा हूँ. इफ यू हैव एनी क्वेश्चन यू कैन ऑलवेज लेट अस नो इन द कमेंट सेक्शन बिलो. थैंक यू.